Hey Geometries, I'm Mr. Bloom and this is Geometry 10-4. Our goal today is to make sure to find the ratio of the areas and perimeters of similar figures. Now we got to recall two figures are similar if their corresponding angles are, excuse me guys, congruent, and their corresponding sides are proportional. Now, the quadrilaterals to the left are similar. They have similar figures. They are all marked. Matter of fact, if I was talking about similar sides, and I was going to do a similarity statement from A to B, it would look like this. 5 to 10. I got 5 is the 10 because it's the quad ringer to the single. And then the single to the double is 2 to 4. 3 to 6. And then we have 1 to 2. Now, if I was going to switch that and go B to A, the quad, which is the 10 to 1, quad 1 like this, the 5 and the 10, I flip it. So it'd be 10 to 5, 4 to 2, 6 to 3, and then we have 2 to 1. Now all of these reduce to 1 over 2 for A to B, or 2 over 1 from B to A. Now we labeled these things A and B, but what's the ratio of corresponding sides A to B? We got 1 to 2, and we could write it 1 to 2, and then we got 2 to 1, but we could also write it 2 over 1. We call the ratio the scale factor, or K, okay? The perimeters and the areas and the area of the polygons have a special relationship. For the perimeter polygon A, I've got 11 meters, okay? Find the perimeter of, and keep in mind, if I talk about that, I go 5 plus 2 plus 3 plus 1. So I'm looking at 11 here. For B, I've got 10 to 4 to 6 to 2. Well, that's 14, 22. So in B, I'll have 22. Now, what do you notice? Okay, the ratio of the perimeters is the same as the ratio of the sides. And those perimeter ratios, A to B, 11 to 22, which becomes that 2 to 1, or 1 to 2 in this case. Or if I went from B to A, it would be 2 to 1. So it's the side ratio that we found here and the perimeter ratio we found here are the same ratio. Now, if the ratio of the sides of two similar figures is A to B, now if the ratio of the sides, of two similar figures is A to B, the ratio of the perimeters is also, what do you think? Because we just found that they're the same. The perimeter ratio and the side ratio are the same, so it should be A to B as well. Now let's look at this next example. We got a 10, we got a 16, we got a 15, we got a 24. The rectangles to the left are similar. Okay, what is the ratio of the sides? Well, the side ratio, 10 to 15, 16 to 24, 2 to 3. Now remember, when you do that side ratio, it's corresponding sides, 10 to 15, 16 to 24. What is the scale factor? Well, our scale factor is 2 to 3, and our K is 2 to 3 like that. So we got to go from our ratio that's either 2 to 3 or 2 to 3, but our K factor's 2 to 3. So this is 2/3 the size of this one. Okay. Now, what's the ratio of the perimeters? All right, the ratios of the perimeters is 52 to 78, because if I go 10 plus 10 plus 16 plus 16, and remember the perimeter here is equal to 10 plus 10 plus 16 plus 16, which comes out to be 52. I'm going to squeak that down a little bit. But I could also look at it as perimeter is equal to 2 times, let's do that right, 2 times 15 plus 24. And my 15 plus 24 is 39, and 2 times 39 becomes 78. That's where I got those numbers. Okay, but now what's the ratio of the perimeters? 2 to 3, or I could write it as 2 to 3. Those are the ratios. And keeping in mind, perimeter ratio and side ratio are the same. Now, let's look at areas. If I take these same two that we just discussed about perimeter ratios, and we talk about their area. Now, the area of A is going to be 10 times 16, because remember, area is going to be equal to base times height. And over here, we're going to do area is equal to base times height. And we got 15 times 24. Well, when I get this area, it's got 160, and I got 360 for the B area. So we labeled them A and B. Okay, so I now have, what's the area of A? Which is 160. What's the area of B? And I know I'm repeating this, but I'm just making sure everybody knows where it's at. What's the ratio of our areas? Well, if I go A to B, my ratio is 160 to 360. Okay, and then I reduce it, which is 4 to 9. Now, recalling our scale factor, which was 10 to 16 to 24, which is 2 to 3, I'm looking at this, and what do you notice about the ratio of the areas? The ratio of the areas, okay, here, and then the scale factors here. Well, both are reduced, but this ratio of the areas seems to be squared, our scale factor squared. And I hope you see that. The perimeter ratio squared is our area ratio. So that's what we've got going on, our perimeter ratio. And keeping in mind what we are looking at here, our perimeter ratio, 2 squared to 3 squared, is equal to our area ratio. And this is our area ratio, and this is our perimeter ratio. Now, if the ratio of the sides of two similar figures is A to B, the ratio of the areas is A squared to B squared. Woohoo! This makes sense because area is two-dimensional. Okay, in summary, okay, this is note card worthy, by the way. If the scale factor of two similar figures is A to B, the ratio of the perimeters is also A to B. Okay, so scale factor A to B, perimeters A to B. The ratio of the areas is A squared to B squared. So okay, so now we're going to go practice this. You're going to turn this off. You're going to answer these two questions. Turn it off. Okay, welcome back. Okay, if the ratio of two similar figures is 5 to 7, what is the ratio of the perimeters? It is perimeter ratio 5 to 7. Yay! Okay, so now we're looking at B. What is the ratio of the sides? Well, keep in mind, the side ratio and the perimeter ratio is the same. So, 5 to 7. Okay, I hope you guys got that. But you know, after I looked at those two, I was like, hey, we're missing a question. So check this one out. Can you answer this one? What is the area ratio? Yep, it's not on your notes. What is the area ratio of the two figures? So keeping in mind, if the perimeter ratio is A to B, then the area ratio is A squared to B squared. In the original problem, we're looking at the fact that the perimeter ratio is 5 to 7. That means the ratio, the area ratio, which is 5 squared and 7 squared, remember that's 5 squared to 7 squared, is now 25 to 49. So those are the basics using ratios in our figures. Now, looking at this next one, two trapezoids are similar. If the scale factor is 3 to 4 and the area of the smallest trapezoid is 81 centimeters squared, what's the area of the larger trapezoid? Well, we're asked to find area. We have a perimeter ratio, and we got to find an area ratio. So, and the reason why we got to find the area ratio is we are looking for an area. Okay, so if I was looking for a length or a side measure, I'd totally use the perimeter ratio. But to get the area ratio is 3 squared to 4 squared, which is 9 to 16. Now I have that. I got 3 squared to 4 squared, which is 9 to 16. But now I got to keep in mind, what am I using? What am I doing? And the area of the smaller trapezoid is 81. Well, which one's the smaller ratio? Well, the smaller one is 9. Okay, so I have a 9 ratio. I'm comparing areas. I place the smaller 81 here because corresponding size should work. And now I just do my cross multiplication. I do 9 times x is equal to 16 times 81. Okay, I divide by 9, and x is equal to 16 times 9, which is 90, and 54, so it's going to be 144. So my larger trapezoid, larger similar trapezoid, is 144 centimeters squared. Now, two triangles are similar. The ratio of the areas is 25 to 36. What is the ratio of the perimeters? Now, a hint, square root of the area ratio. Oh, square root of the area ratio. So basically, remember, if it's perimeter, it's a to b, and the root is a squared to b squared. This is my area. If you go back, I take the square root of. So I'm going to take the square root of 25 and 36 and find my perimeter ratio to be 5 to 6. So we've got that one nailed down. Now, the figures below are similar. The area of one is given. Find the area of the other. So this one's 36. Now, I am fully aware right now you're thinking, well, they're both squares, Bloom. Why are you about to do what you're going to do? I want to make sure you recognize how this works. If this is 5, and this is area 1, and this is 6, and this is area 2, that's what we're looking at. The figure below are similar. The area of 1 is given. Find the area of the other. Well, this is just to help us understand this ratio thing. I have a perimeter ratio of 5 to 6. I have an area ratio of 25 to 36. Okay, so I can look at this and go, hey, I know I'm going to compare areas. So the small area is 25, the big area is 36. I have the big area, and I'm looking for the small area, which they're saying is 1. A1. But now keep in mind, these were squares. So we could actually just say this is 25 to 36, but I want to make sure that ratio relationship that we were working on makes sense. Now we're going to multiply by 25. I divide by 36, and A is 25. So that's basically what we're doing on every one of those problems. So we know that A1 is 25 meters squared. All right. So now our last one here, and we did that one just to make sure we see it. We got a perimeter ratio of 9 to 4. That's our P ratio. Our area ratio is 81 to 16. Okay, the area of the smaller pentagon is 20. 20 is the smaller. What's the larger? So we're looking at this. So we're going to do some cross multiplication, and we have 81. So we're looking for this one. We got 16 times x and 81 times 20. So 81 times 20 is going to be 1620. Then we got 16x. I'm going to take that 1620 and divide by 16, and I get x is equal to 101.25. And that is centimeters squared because it's area. Okay, so the area of the larger is 101.25 centimeters squared. Now, that's what I've got for 10-4. And extra questions you'll have to your local geometry teacher. I guess, really, as always, I'm Mr. Bloom, and you're not. Happy guys and gals.